right, on this page, we're going to be talking about how about algebraically. So the previous page was on graphs. This one is on equations and algebra, like doing them, what happens. Well, remember that the inverse switches the x with the y. And so a lot of times the question will be, okay, if this is the function, what is the inverse of the function? And the way we do that is, do you remember that f of x really just means y? So to find the inverse of the function, we're going to switch the x with the y because that's what an inverse does. It switches the x with the y. So I'm going to take this function, I'm going to rewrite it and say, no, actually x equals 4 minus 3y. So I just switch my x with my y. But now what I need to do is I need to solve for the other variable. I'm solving for y now. And remember, to solve for equations for the other variable, you take your order of operations and you go backwards. So in other words, I'm going to start with adding and subtracting. I need to subtract this 4 first. And so I'm going to get x minus 4 is equal to negative 3y. PEMDAS backwards says, okay, we need to multiply divide now. So I'm going to divide by a negative 3. And so what I get, I'm out of space up here, so I'm going to come up here. I have y equals x minus 4 over negative 3. And I can just leave it like this, or I can split it up into two fractions. Different people like to do it differently. But what we've just done is we've found the inverse function. And the notation for the inverse function is f to the negative first power. That means inverse. Okay, so my inverse function is x minus 4 over negative 3. Let's try another example. So remember, this is actually a y, right? I'm going to switch my x with my y. All right, so I now have, when I switch my x and my y, I have x equals 5y squared minus 2. I need to solve for y. To solve for y, I need to add 2 to both sides. And then I need to divide by 5. And lastly, I need to take the square root. And remember that when I take the square root in the middle of solving an equation, that I have to give my plus and minus. So I'm going to finish out my problem now. It's going to be y equals plus and minus the square root of x plus 2 over 5. And really when I give my answer, I want to give it in this inverse function notation that is f to the negative 1 of x. And so f to the negative 1 of x is the square root of positive and negative square root of x plus 2 all over 5. So that is my inverse function right there. Remember, an inverse function should do the opposite operations. So this was a square, this is a square root. This has a minus 2, this has a plus 2. This has a times 5, this has a divided by 5. So that's how we know that these are inverse functions. All right, let's try another one. We want to change our x and y, and now we want to solve for y. So I need to square both sides. And then I need to subtract my 3. And finally, I need to divide by negative 2. And so I get y is negative x squared minus 3 all over negative 2. I might want to rewrite that, I probably do, into function notation and have my inverse of f of x is this. Okay, last one real quick. I'm going to take the cube root on both sides. Then I'm going to add 1. And when I add my 1, it does not get added inside the cube root. It's added outside of it, so just be aware of that. So my inverse function, my inverse of x, is the cube root of x plus 1. Concept 4, on the previous slide we talked about that they are inverses of each other, and that means they both simplify down to x. So in other words, f of g of x is equal to x, and g of f of x is equal to x. Because if they are inverse operations, then like everything cancels out except for the x. And so the question, are these functions inverses? The way we're going to answer that question is we are going to see, does f of g of x equal x, and does g of f of x equals x? So we're going to take a look here. So for instance, if we take f of g of x, then I'm going to take my function from f of x, and I'm going to plug in g of x in for the x. And I accidentally had a fifth power. That fifth power is not there. The fifth power is on the inside. So now we're going to put an x to the fifth minus 2 because that's what my function from g of x was. Well, if I look at this, I can simplify that stuff inside the parentheses there. Because negative 2 plus 2 is just 0. And so those add up and they kind of drop off there. So really, I can just simplify that to f of g of x is the fifth root of x to the fifth. And we know, because we've talked about this last week, that the fifth root of x to the fifth is just x. So it did just what we thought it would do. So it looks like they probably are inverses. We ought to check the other one just to make sure. And so that means we're going to go the other way. We're going to take f of x and plug it into g of x. So my g of x equation is x to the fifth minus 2. I'm going to plug in this into my x where the x was. So I'm going to put the fifth root of x plus 2 here. And take that to the fifth. They cancel out. And so I just get x plus 2 minus 2. Well, yes, x plus 2 minus 2 does equal x. So yes, these are inverses because f of g of x cancels to x and g of f of x cancels to x. Now, could we have seen that from just looking? Maybe, because this is a minus 2, this is a plus 2, this is a fifth, and this is a fifth root, so they certainly look like it. But sometimes you just have to be careful and test it, because sometimes it looks like maybe it would, and ends up it doesn't. Let's take this one as an example. So let's again try f of g of x. So I'm going to take g of x, and I'm going to plug it into that x, so I get this. Now, do these cancel out? Like, are those 3's going to cancel? Is that, no, it's not going to go down to, I need this somehow to go down to x. Does not look to me like it's going to do that. So they are not inverses because they do not cancel down to just x. Okay, finally, why do we care? What are we even doing? Well, in word problems, it allows you to solve for something different. And so, like, if you are given the volume and you want to find length, then maybe you solve it for L instead of solving it for V. So let me show you another example. So when we do word problems, we don't switch the variables. We don't change the letters themselves because in word problems, those letters mean something. Like up here, f of x and y and x, they're just variables. They just stand for something, but we don't know what that thing is. And yet in word problems, they actually carry some meaning. So we're going to leave the letter the same, but we still want to solve for the other variable. So for instance, I'm going to take this equation. I'm going to take out that x because that's just confusing to me. And I'm just going to say z equals x minus 250 over 40. But I want to solve for x. So I need to multiply by 40. And then I need to add 250 to the other side. All right, so I get x equals 40z plus 250. That is finding it. We did that. Interpreting it. What does that mean? Let me explain what's going on here. If you take a standardized test, for instance, an AP test, and you get a certain score, like on the AP, you get a 1, 2, 3, 4, or 5. Well, there are more than 5 questions on that test. And so your raw score is like your actual score. That's like your X. So maybe there's, 500 points possible. They give each multiple choice a certain amount. They give each free response a certain amount. And so this equation lets the graders say, well, if a person got this score, I plug it into this equation and I find out if they got a 5, 4, 3, 2, 1. But then you get your score back and you're like, I got a 3. What does a 3 even mean? I wonder how many I got right. Well, that's what this equation does. So this first equation lets the grader look at your score and convert it to a 5, 4, 3, 2, 1. Whereas this equation lets you get your 5, 4, 3, 2, 1 and change it back to, I wonder how many I got right. So I'm saying that the inverse calculates the total score given your standardized score. Whereas what they did before is they calculated the standardized score given your raw score. So it just allows you to solve for a different variable, kind of go backwards from what was calculated before. The second part of this question says, if a person's standardized score on a test was 2.5, what was the person's actual score on the test? So this is what I'm saying, like you get your score back. What does that mean? So you could use either one of these equations. If you wanted to use this top equation, you certainly could do that. So to do that, you would put your 2.5 over here, and then you would solve. But you could do it another way too, which is a little bit easier, is you could solve using this equation. And you could say, okay, what is my x when they say I got a 2.5 on that equation, on that test? So now you can solve for the other variable. And this way just is a little bit easier than going through all of this. That's all it does. So you plug in all your information and you find out that X is 350. That means your raw score was 350 and your standardized score was a 2.5. All right, so that is what we know about inverses and how to use them, why we do them. We will practice on this in class.